All right. Yeah, I'm Flynn. I am a tech evangelist with Buoyant, working on Linkerd, basically spreading the good word about Linkerd and all things cloud native with Kubernetes and all that. And maybe more importantly, trying to make sure that people actually understand how to use Linkerd and all these tools. Today, we are going to be talking about startup. Deep dive into what happens in Kubernetes when you're actually starting to run an application with Linkerd. We're going to be talking about Kubernetes startup and Linkerd startup and init containers and CNI plugins and a lot of stuff that may end up being more than you ever wanted to know about this topic. So we'll find out. As we go through here, if you have questions, you can put them in the chat, you can put them in Slack. Feel free to do that at any point, and Jason will interrupt me whenever he thinks is relevant. The agenda for today is a little different. We try to do these with kind of relatively few slides and relatively more hands-on stuff. Today is a little more slide heavy than usual. There's a lot of rather complex stuff that we need to cover, so bear with us. We will still do some hands-on work at the end, I promise. And with respect to the hands-on work, normally we say just bring a cluster, any cluster, it doesn't matter what kind. As we mess with the CNI today, I'm going to be doing it with K3D. The stuff that I'm doing is only known to work with K3D. Before we get to the CNI, we're going to be doing stuff that will work on any cluster, though, so don't panic too much. Okay. With that being said, onward. We're going to start talking a little bit about Kubernetes itself from a far too high a level here, but it is important to remember that nobody runs Kubernetes just to say they're running Kubernetes. People run Kubernetes because they want to get things done. They have specific workloads that they actually want to be able to execute for people. And if we look at this from a really high level, we start off with our workloads. We get some hardware, which in Kubernetes land is called a node. And some of our workloads get scheduled as what Kubernetes calls pods onto the node. You're not required to have only one node. You will usually have more than one. And you can spread the workloads across the nodes. So far, so good, right? The pods actually exist inside these other things called deployments. I'm deliberately overgeneralizing here, talking about deployments instead of daemon sets and replicate sets and all that crap. They're basically kind of the same thing. We'll talk a little bit more about that later. And all of this fits into a cluster. Again, this is the very, very overgeneralized view of Kubernetes. If we head down into the rabbit hole a little bit, things get a little weirder. So we have our cluster. This is a 3-node cluster because, why not? The first place that we have to clear up as we go further into the rabbit hole is that the deployments don't actually live in the nodes at all. They just are associated with the cluster. They also don't contain pods. They contain templates from which we can instantiate pods inside the nodes. Kubernetes gets to decide which pods run on which nodes. It actually is possible to have a cluster with a node that's not running any pods. It's not common, but it is possible. And it's also worth pointing out, here we have 3 deployments. If I change one of those deployments into a daemon set, the machinery pretty much works the same, but the big difference is that now the daemon set will guarantee that we have exactly one pod of that daemon set running on each node. And this will be important later. Okay, if we drill a little bit further down still, and we look at into the nodes in particular, here we have 2 nodes. We've got one node running a green pod and a yellow pod, and another one running a red pod and a yellow pod with our daemon set. Kubernetes will arrange it so that the green pod can talk to the yellow pod, but also it arranges it so that the green pod can talk to the red pod, even though it's in another node. This is a very important characteristic of Kubernetes. There's a requirement in Kubernetes that the network is flat. So you can talk within your node as easily as you can talk outside of your node. And that is something that Kubernetes goes to a lot of trouble to make certain of. Now, if we continue looking further into here, the way networking actually works is that for each of these pods, there's an IP address associated with that specific pod and only that specific pod. And then we also have the Kubernetes service objects, where we can put in a label selector that associates a particular set of pods with our service. From the pods, we look at the set of matching pods, then we look at their pod IP address, and we bring those pod IP addresses into the service and call them the endpoints associated with that service. But there's one more magic bit here that we need to talk about, which is the cluster IP. Once you create the service allocates an IP address in the cluster that is different from any of the pod IP addresses and different from everything else, and arranges it so that when you talk to that cluster IP, when some other workload talks to it, Kubernetes goes through and messes with the networking stuff on the host so that it will route from the cluster IP and magically take it under the hood to one of the pod IPs. Okay, everybody with me so far? Now is a great time to throw questions in chat if any of this is confusing. All right. So that means we can go a little bit further down the rabbit hole and look at what actually happens at a deeper level when our green pod tries to talk to our red pod. It actually is going to talk to the cluster IP for the red pod, and then that's going to be redirected into the actual pod for the red pod. Trying to actually say this out loud, there's way too many instances of pod in that sentence, so sorry about that. A similar thing happens if the green pod tries to talk to the yellow pod. And the interesting thing here is that even though we're showing, we've got the green pod trying to talk to the yellow cluster IP, we've got the red pod trying to talk to the yellow cluster IP. I'm showing these as two separate things, even though it's the same IP address, because since Kubernetes knows that the yellow pods are in the same cluster, in the same node, it never actually goes out into the rest of the cluster. It gets wrapped back completely inside the node. Okay. From there, we can start talking a little bit about how Kubernetes actually does this. Remember, the nodes are mostly separate hardware. They might be virtualized hardware, they might be real hardware, but in order for the kernel running on the node, and there's only one kernel per node, in order for the kernel running on the node to talk to the kernel running on another node, it's going to have to use an IC driver to actually interact with real or virtualized network hardware. Then there's a second layer called IP tables, which is where all the magic of rewriting IP addresses and doing all the specialized routing happens. So the green pod talking to the cluster IP for the red pod will get intercepted by IP tables. IP tables will realize, oh, I need to talk off the node to get to the actual pod here. So it'll throw it into the NIC driver. And then IP tables on the other node will grab it and redirect it to the appropriate container inside the node. Similar thing happens when we talk to the yellow pod from the green pod. But here, the IP tables layer realizes, hey, this is something local to my node. And so it just redirects it internally. The NIC driver never gets involved. The traffic never leaves the node. Same thing happens on the other side, going to the yellow pod on our other node without ever leaving that node. All right. What do you think, Jason? Is this making sense, or am I just losing everybody? I'm not getting any questions, so I'm kind of worried. Hey, we just got a question.
Yeah, I was gonna say. Ismail, are you trying to say where is the redirect logic being implemented? Okay, where is the redirect logic being implemented?
So there's kind of two ways we can answer that. The first one is that the mechanical part of finding the IP address, noticing that you're talking to a given IP address, and then redirecting it to a different place, that's all happening on IP tables. There's a second layer of how does IP tables know where the pod lives? And at the level we're talking about so far, that's handled by a component within Kubernetes called kubeproxy, at a, kind of very broadly speaking. So if that answers the question, if that does not answer the question, please let me know. Looking over some of these other ones, if you ask us which service mesh is preferred and awesome, we will of course tell you it's Linkerd, obviously. And we'll save a more nuanced discussion about that for the end, just because I'm a little concerned about running out of time. Load balancing by services. That is actually a really good question. will there be load balancing at the cluster IP level if there is also a pod on the same machine or the same node? It will do load balancing across nodes, even if there's a pod on the same node, I think. But Mate, if you happen to know better than I do there, now would be a lovely time to chime in.
Just actually a quick pause,
yeah.
folks. If you're asking these questions in the Zoom chat, if you could consider joining the Linkerd Slack, slack.linkerd.io, post about it in there a couple times, and asking these things on the workshops channel. It becomes easier to have more nuanced discussions because we can do threads and the questions persist longer. So at least consider it. And thank you so much for the questions we've got.
Yep. Alternatives to IP tables. I'm using IP tables to refer to the entire broad class of things that do this level of rewrite. So IP tables, the legacy thing, or IP tables in FT, or whatever, right? Insert your favorite kernel level rewrite thing here. That's really going to depend on what kind of cluster you're running and how they set it up, though. Does the kernel do the packet processing? We will get to that in a moment. Let's see. Interviewer asking about.
Well, yeah, I'm happy to take it.
We'll take that one offline in the chat. Okay, and Mate. Yes, it turns out I was right that it will indeed still load balance. All right. Thanks for all the questions. Very nice. Onward. So it's always nice when Mate agrees I'm right. It doesn't happen very often. Okay, so similar thing happens when you're trying to talk to something that's not on the same node, where in our application container here, the green one talking to the red cluster IP will just go ahead and get bounced up into the NIC driver and head off. Okay. Now, let's think about what happens when we're dealing with things like, oh, actually, I'm sorry, I misspoke a moment there. The important distinction here is really, in this slide, I'm talking about pods. But if we zoom into the pod itself, so now we're looking at only one node. Inside the pod, it's really an application container, by which I mean a container running the application code that you've decided to define, because pods can have multiple containers, and the multiple containers can independently communicate with each other. So in this case, this is really just showing that the things that we used to be calling the pod as the whole is really a container inside the pod that can go through and do the right thing. All right. This becomes very important when we're running Linkerd, because when we're running Linkerd, there is not just one container there. There is also the Linkerd sidecar proxy. And the Linkerd sidecar is the thing that handles Linkerd's logic about where pods live, which pod should be talked to. So Linkerd can do load balancing at this level. And importantly, Linkerd can do things like, for example, gRPC request load balancing and things like that, that doesn't rely just on a connection. So what is really going on as soon as Linkerd gets involved is that our application container tries to talk to a cluster IP, IP tables grabs that, redirects it to the Linkerd sidecar. In this particular case, the Linkerd sidecar will go, okay, well, he's trying to talk to the yellow cluster IP. It will then find an endpoint IP for the specific endpoint it wants to use for load balancing purposes, toss that over. IP tables will grab the packet going to the endpoint IP, bounce it to the Linkerd sidecar next to the application container in question, and then the Linkerd sidecar will speak through localhost to the application container. So this is far enough down the rabbit hole that we can consider it basically to be reality. Nothing else was real in that sense. If we look at that when we're trying to talk to something that's not in the same node, it still goes to our local application container, or sorry, our local Linkerd sidecar, which will then go to, again, an endpoint IP, but in this case, IP tables recognizes that that endpoint IP is not in this node, and so it goes ahead and tosses it out. Ultimately, it will probably be caught by another Linkerd sidecar in another node, although there are ways you could arrange it so that it doesn't have to be caught by a Linkerd sidecar. Another important point here is that if the yellow container tries to talk to the same cluster IP, it will not go to this Linkerd sidecar. It will go to this one because that's the sidecar that belongs to the yellow application container. Okay. Any other questions?
We have one actually, but one of our attendees answered it really well.
That would be.
I'm just letting them know how to make it so they send the message directly to Chris. And Dan, by the way, thank you for that.
Yes, indeed. Okay. All right, so let's go ahead and continue then.
Kevin Yang asked a great question.
Why can't the application talk to the sidecar directly? It could if you modified your application, but we don't want you to make you modify your application. Your application should be able to run exactly the same as if it's running inside Linkerd or if it's running outside Linkerd. And the only way to do that is to arrange it so that we actually capture the connection going to the cluster IP and redirect it to the sidecar, because any other way of doing it requires you to recompile your application or possibly rewrite your application even. Okay. Anything else? We good? All right. The kind of the obvious question is, we're talking about all this very, very fancy stuff going on at the networking layer and all this redirection and all these sidecars, which raises the question of how in the world is all this stuff configured? And that gets us into the whole startup question. There are two possibilities, two ways that Linkerd can go through and configure all of this stuff for you. One of them is it can use a Kubernetes init container, and the other one is it can use a Kubernetes CNI plugin. There are, of course, multiple paths that happen with both of these methods that we can talk about. Only one of those paths is happy, and there are multiple ways that things can go wrong and get you on a less happy path where nothing is working right. So we're going to start off talking about the init container. What is happening here is, and I'm kind of deliberately glossing over one important step here, but you create a pod with your application container, and Linkerd will actually go through and tweak that. We have a mutating, excuse me, we have a mutating emission controller, which we call the proxy injector. So the proxy injector will put this init container in there, and it will put the Linkerd sidecar in there. Init containers are guaranteed by Kubernetes to always run first. They must run to completion before anything else gets to happen. So the init container starts running, and the init container is the one that configures IP tables on the host, on the node, to say, hey, yeah, here's a cluster IP, I got a sidecar, all that, and does the right thing. At that point, the init container finishes, which frees up the rest of startup to continue. The next thing that happens is that on the happy path, the sidecar starts running. We really want this to happen second, because the sidecar is the thing that needs to be able to catch all of the networking requests, right? So the sidecar starts running, and then the application container starts running, and then the application container goes and makes network requests, and good things happen. That was the happy path. There are a lot of less happy paths here. One of them is, although Kubernetes guarantees that the init container must finish before anything else starts, the sidecar is just an ordinary container, and there is no particular ordering in place for startup of non-init containers. So it is entirely possible that the application pod could start running before the Linkerd sidecar. That would be problematic, because until the sidecar is running, the application container is not going to be able to talk on the network at all. The good news about this particular failure mode is that it tends to be self-healing. As long as your application isn't doing something truly insane, then eventually the application will be able to talk on the network. And if you have properly configured startup probes, for example, then Kubernetes probably won't start routing traffic to you until after the network works and the probes can come through and all that kind of stuff, right? So usually self-healing-ish. But it's a big enough problem that as of Linkerd 2.11, we actually modify the deployment to prevent that from happening. The way we do that is there's an annotation config.linkerd.io/proxy-await. If that is enabled, which is the default, then the proxy injector will do two things. The first one is it will force the Linkerd sidecar to be first in the list, because Kubernetes actually does run through and start things in order. It just doesn't wait for anything before starting the next one, unless you include a post start hook on one of your containers. Kubernetes also guarantees that if you have a post start hook, the post start hook must complete before it continues starting the next container. So we put in a post start hook that actually waits until IP tables has been configured by the init container, but then it will exit, and then it will allow the rest of your application to start up. You can disable this by saying config.linkerd.io/proxy-await equals disabled. It's not entirely clear to me why you would do that, because it introduces this fascinating race condition, but you know, you do you. If this is a thing that'll help you, go right ahead. Other less happy paths. Your init container might not actually have permission to go and mess with IP tables at all. The thing that you need to be able to mess with IP tables is the netadmin capability. There are clusters and Kubernetes runtimes and cluster providers that simply will not allow this capability to be set on a container that's coming in, because they're, I don't know, concerned about people messing with it and breaking everybody else. This one, you can't really get around that with an init container. It basically boils down to, if you have this problem, you need to be using the CNI plugin instead of an init container. In a similar vein, if you are running Kubernetes and your nodes are running an operating system in the Red Hat family, then they may have dropped legacy IP table support, in which case you might need to go and switch to using IP tables in FT. I think that came up, I can't remember if that was as of Linkerd 2.10 or 2.11. Matej, if you actually, yeah, Matej, if you remember when that showed up, I would love it if you would put that in the chat. There's a fairly recent sort of change. And, you know, it's not something you're likely to need. Oh, Dan Williams says 2.12. Man, more recent than I thought then. So yeah, if you're running an OS that requires this, then go ahead and upgrade. Or again, you can always just use the CNI plugin. That will work as well. Okay. Other questions? Anything?
Looks like things are going smooth. Oh, wait, nope, we have one from Roger. What
Okay.
does the application init container or other potentially injected init containers run?
Are you asking what code they run? Because the init container, basically the init container is defined. Oh,
sorry,
when. Okay, got it. Init containers run right after pod startup. Okay, almost right after pod startup. We'll get to that in a moment. They run before any other containers start, and they are required to run to completion before any other containers start. Does that answer your question? That's a thing that Kubernetes actually guarantees for you. Chris O'Connell asks about the difference between the CNI plugin and the init container, which is in fact the next thing in this workshop. Roger clarifies if there are multiple init containers. That's actually a really lovely question. Matej, do you remember? I have this vague idea that our init container, that the proxy injector puts our init container last, but I am not actually sure about that. That would be a great question to take to the workshops channel on Slack, actually.
All right, Noah
Good.
asks.
Matej says it's supposed to put it last. Yes.
Noah asks if the CNI plugin can be used in conjunction with my existing CNI, or does it replace it?
It is used in conjunction, and we will talk about that as well coming up.
Okay.
Sorry, I had a funny expression on my face because I was only mostly sure it was already in the slides. It's yeah. Let's make sure we cover that. Okay. Onward. Onward if I can find my mouse. Okay.
Folks, once again, if you're asking questions in the Zoom chat, they persist, and it's a lot easier to make sure we don't miss anything if we put it over in the workshops channel in the Linkerd Slack.
And actually, before we get into the CNI thing, we kind of talked about this. I may or may not have added this slide kind of right before the workshop. The most common failure modes, if you are having an issue with your init container, is the most common one is just you'll see delays or restarts as your pods are trying to come up. If they're coming up in the wrong order or something like that, then that will be possibly slowly resolved by Kubernetes eventual consistency. This is the thing that proxy await was invented to deal with. So yeah, I would encourage you to use that. If you cannot provide the netadmin capability, on the other hand, that is not a subtle failure. That's just nothing will happen. Your pods will not come up. They will not run. You'll see them and crash loop back off. It's just, you know, a bad situation all the way around. Okay. All right, on to the CNI plugin. So CNI plugins are a little weird, a little weirder. What happens is once the node is created, then there is a Linkerd daemon set for managing the Linkerd CNI plugin. Once the node gets created, the daemon set gets scheduled onto the node, which then creates a daemon set pod, whose sole purpose in life is to install the Linkerd CNI plugin into the node. With respect to the question about other CNI plugins, the daemon set tries really, really hard to put the Linkerd CNI plugin last. Again, much like the init container. After the daemon set installs the Linkerd CNI, it just goes idle and sits there waiting to see if there are changes coming on to the list of CNI plugins. If you install another CNI plugin after that, the Linkerd CNI daemon set will try really hard to move the Linkerd plugin to be last in the list. The Linkerd CNI plugin also tries really, really hard to do no harm with respect to other ones. If you run into a problem that you think is caused by that, we would love to hear about it. Okay, once this happens and you go ahead and you create a pod, again, we're going to have an init container, although it's running slightly different code now. We'll have your application container. We have the Linkerd sidecar. But the first thing that happens as soon as the pod is created is that the Kubernetes container runtime then goes through and runs the CNI plugins, including Linkerd's. And the Linkerd CNI plugin will configure IP tables for you. And then it will finish, which allows pod startup to continue. The init container that happens when you're using a CNI plugin actually doesn't do anything except to check to see if it looks like IP tables has been properly configured. If it has, great. If not, not so great. We'll talk about that in a little bit. As soon as it decides that the IP table setup is correct, it will exit, which allows the rest of startup to happen. So the sidecar will start, the application container will start, and then basically everything else happens the way that you've seen it before, except that this time we don't actually need the netadmin capability at all. Zoom just said that Ahmed raised a hand. Oh, okay. That was not a real hand raise. Got it. All right. So that's the happy path. Let's talk about less happy paths with CNI. The first kind of unpleasant one here is that daemon set pods are not treated particularly specially by Kubernetes. They are treated specially in the sense that exactly one of them will be running on every node, but their ordering and scheduling and their priority in scheduling is not treated in any way, is not treated specially. That leaves us the possibility that the application pod will get scheduled before the daemon set is running that will be installing the CNI plugin for you. This is not a good scenario because at that point, once the pod comes up, the runtime does not see a CNI plugin to run for Linkerd, so it doesn't run it. So the Linkerd CNI plugin cannot configure IP tables. So now your pod is started and running, and it's basically screwed because it can't talk on the network properly. Before Linkerd Edge 22.10.3, this tended to fail sort of unpleasantly. The most likely scenario would be that the pod just simply wouldn't start because the health checks would fail. As of Edge 22.10.3, the init container actually contains the validator, which will check the IP tables and exit if something goes wrong. So the init container will come up, check IP tables. If something goes wrong, it will immediately exit, and that will cause a crash loop in the init container, which will cause something that is obviously wrong when you look at your pods later. That will be a part of Linkerd stable 2.13, but for right now, you still have to get that with an edge release. And sorry. I'm looking forward to having it in 2.13 though. Virgil asking, doesn't pod quality of service help? It can if you set it up correctly, but relying on that in the entire world is not a great idea. We'd rather do stuff a little bit more robust than relying on the operator to get that right. Okay. Other less happy paths. Oh, wait. Why do health checks fails? Is the health check request by Kubernetes routed to the application pod directly on its port? The short answer is that depends on what the rest of Linkerd is doing and things like that. That would be a really good one to take into Slack, actually. That also might be a case where Mate just wants to say that I'm wrong about that. And it's not so much that health checks fail, it's that the application doesn't get to talk and doesn't get to run. All right. Other less happy paths. There was a question about, well, can this work with multiple CNI plugins? The answer is yes. The common case really is that people have more than one CNI plugin when they're using this stuff. And CNI is a little bit interesting. It has a way to specify the order in which plugins will run, but CNI as a whole is really interesting. It was pretty clearly designed with the intention that the cluster provider, the cluster administrator, and by cluster administrator, think the people running things like GKE, the CNI was really designed for them to be able to go through, set up all the CNI stuff before anybody else interacts with the pod, and not really for end users like y'all using Linkerd to be able to mess with this stuff. The problem with that is that it means that you land in a situation where if you do things the way the CNI, strictly the way the CNI plugin was designed, then you cannot do things like, oh, I'm going to try K3D, but let me try it with this CNI to see how that works. Let me do this developmental experiment. And so people tend not to use it the way that the CNI stuff was really designed. Instead, they tend to just go ahead and mess with it at runtime. So Linkerd's solution here to allow people to mess with it at runtime and still try to play nicely with any other CNI plugins is, again, we have an installer daemon set that will watch the CNI list changing, and then it will try very, very hard to put our CNI plugin last so that all of the networking stuff that Linkerd needs will do the right thing. We also try really hard not to stomp on things that anybody else does in IP tables. So we try really hard to play nicely with any other CNI plugin we see. It's possible that you will see us get this wrong in some cases. And if you do, we'd love to hear about it. The typical thing you'll see here is that it will prevent your pods from being able to talk on the network at all. And they won't start running and bad things will happen. Finally, CNI is a standard, but it's not necessarily something that gets used in exactly the same way on every kind of cluster, or indeed on every instance of a cluster. So it is possible to misconfigure the CNI plugin in the first place. Again, this will typically prevent the pods from coming up at all. And you may also, for this one, see corrupt message errors in the proxy logs for the pods in the Linkerd namespace. That's a pretty good indication that something is wrong with the way you've set up the CNI in the first place. Okay. The sort of good news is that CNI failures are typically not subtle things that you can miss. They are typically large and excessive and not the sort of thing that you can possibly fail to notice. The bad news is that they can kind of end up looking the same, and it can be very, very difficult to go through and figure out what exactly it is. We are definitely not going to have time today to go through too much on the whole CNI debugging thing, but we do have a couple of guidelines. One of them is kind of the obvious: look at the installation guide for the CNI you're using really, really carefully and make sure that you didn't miss anything when installing things, when setting it up. Another one is, and this can be very problematic on some clusters, you will generally need access to the node itself rather than to a pod within the node to really get a sense of what's going on in the CNI. So for K3D, you can use Docker exec and just go in, poke around. On the other hand, for some of the cloud providers, you may not be able to get access to the node at all. I don't really have a good solution to that other than consider other cloud providers. But yeah, that's one of the things that I personally find kind of frustrating about the cloud provider clusters. And finally, hey, we're always around on Slack. If you're trying to use Linkerd and you're finding that something is going on, you think it's the CNI, bring it up to us on the Slack channel. We'll see if we can help. Okay, any other questions? Because the next thing we're going to do is the demo, which is going to involve a whole lot of crossed fingers and praying to the demo gods today. I'm not seeing any questions so far. Anybody? I don't know. Anything come to mind, Jason? I'll put Jason on the spot. That's always entertaining.
No, I think this has been, at least from my side, it's been really informative and helpful. Thank you. I'm looking forward to the demo.
I'm looking forward to seeing if the demo works. It's possible. It is, yeah, it is possible today, people, that I was changing the demo and making little tweaks pretty much right up to start time. So it'll be fun to see what happens. We'll see if the demo gods are with us. All right, let's get to it then. So we're going to start actually by installing Linkerd Edge 22.11.1. This is the most recent Edge release. It came out Friday, I want to say, so it's less than a week old. And we're going to do this because I want the CNI validator that will be part of stable 2.13, because I want to show you how that's going to look. Okay, so let's make sure that actually worked. That's kind of lovely, but I'm going to take that as Linkerd Edge 22.11.1 ran, so I'm kind of happy with that. Okay, next up, we're going to create a K3D cluster. We're going to do this without any CNI stuff right now. We're just going to be using the normal init container thing, and hopefully we will land on the happy path. We're going to, okay, we didn't have an old one, good. And we're going to make sure that when we start K3D, we tell it explicitly, please don't deploy traffic, because it doesn't make sense. We're going to be using Linkerd. So off we go. Oh, I just figured out why my Linkerd version didn't work. It's because I had no Kubernetes cluster running at all. So we should modify that so it will at least tell you the client version, even if you don't have a Kubernetes version or Kubernetes cluster defined, Okay, here we go. We have our cluster. Next up, let's take a quick look just to see what's running in here. We've got our usual kube system and default and all that. We can see things that are the usual suspects for K3D cluster. So far, so good. I'm a little concerned that my metrics server isn't quite ready yet, but I also don't really care because I'm not going to be looking much at the metrics. And I mean, it's only been 15 seconds, so fine. Okay, let's make sure that Linkerd will be happy with this cluster. Okay, Linkerd should be happy. We ended up getting a green check mark at the end, as we like. So off we go. We're going to go ahead and install Linkerd. This is all so far. This is straight out of the Linkerd quick start. So we install the CRDs, as you must after 2.12, and then we install Linkerd itself, and then we make sure everything is running. I've gotten into the habit for demos of actually setting a timer, because because there are times I've managed to screw up things in my cluster badly enough that Linkerd just doesn't run at all. It's kind of entertaining. But in this case, I can see it going to from no pods to not ready. So this is a good sign. Sharik has a question. How many CRDs? You mean how many CRDs does Linkerd install? Looks like,
I think we're at 6 at the moment.
I think we're at 6 at the moment. 1, 2, 3, 4, 5, 6, 7. How are we at 7?
7.
Oh yeah, we have to count server authorizations, even though that's kind of deprecated. Well, it kind of depends, right? You can look at it as we shouldn't count server authorizations because it's deprecated, or you can look at it as we shouldn't count HTTP routes because that's part of the gateway API, and we will soon enough be taking that from the gateway API. So 6 for real. Okay. Linkerd claims to be running. That's good. So let's take a look at the cluster now that Linkerd is running. And the only thing that's different in namespaces is we have a Linkerd namespace now. There's nothing different in kubesystem, which is good. And we can see that things are running and fully ready in the Linkerd namespace, where Linkerd identity, destination, and proxy injector are the usual suspects for Linkerd. Linkerd identity manages all of the workload identity magic. Linkerd destination is the thing that keeps track of how routing is supposed to work within the Linkerd cluster, Linkerd mesh, excuse me. And the proxy injector, as we mentioned earlier, is a mutating admission controller that modifies deployments on their way in to actually have sidecars and things like that. Okay, we're going to go ahead and install an application as well, just so we can look at stuff in the context of an application rather than going and rooting around in the Linkerd pods, which are a little, different. Okay. All of this is from the Emojiboto quick start, and the actual application that we're using is frankly kind of irrelevant here. I just picked on Emojiboto because I happen to have the install instructions lying around. So what's running in the Emojiboto namespace? There are 4 different deployments running, each of which has 1 pod. Each pod has more than 1 container. So let's go and take a look at the emoji pod to see what's actually in it. I probably should have subtitled this talk far too much JSON path. So if you're not familiar with JSON path, you're about to get a tutorial in it. When we go and get a list of pods, then the object that comes back is a Kubernetes list data structure. So it has an element called items, which is an array. We're going to look at the first item in the array, haul out its metadata object, and then look into that and get its name. Since we're getting a pod, the first item in the array should be a pod. And pod.metadata.name is, in fact, the, just the name of the pod. So the point of doing that is, of course, that we are then going to go and examine that specific pod more, in more detail. And so we needed its name. So we're going to we found a pod with this name. We're going to use that pod to fetch that out. We're going to look over all of the containers in its spec, and we're going to haul out the name of those containers. Range gets bracketed by end, and this is a literal new line. So what we expect to see is a list of container names separated by new lines. And in fact, we have containers named Linkerd proxy and emoji service. Linkerd proxy is the Linkerd sidecar, and as promised by proxy await, which is set by default, the Linkerd proxy comes first in the list, and then emoji service, which is our application container, comes after that. So let's take a look at the lifecycle hooks that are set on each of these containers, because in theory, proxy await will have set a post start on the proxy, right? So same sort of thing. We're looking over each container. We're going to haul out its name. We're going to do the word lifecycle in a new line, and then we'll haul out the lifecycle object, stick in a couple of new lines, and then end the range. So if we look at that, we can see that the Linkerd proxy does indeed have a post start. It's running the magic command Linkerd await, but the emoji service pod container, excuse me, the emoji service container does not have any lifecycle hooks associated at all. So far, it appears that the proxy await stuff is doing what it ought to be doing, which is good. One thing that I found that was kind of interesting is that if you really want to verify if proxy await is active, looking for that post start hook is the best thing you can do. I was kind of expecting that I was going to see an environment variable or something like that, but no, it's just the post start. So, questions so far. What I'm seeing at the moment is mostly mockery about.
No, we're good to go. We had a great
Various
question
things.
in the Slack,
Oh, yeah,
but we was answered there, and we're moving forward.
awesome. Okay, so you will note that we didn't actually see any mention of init containers in that container list, and the reason for that is that init containers have their very own element in spec. It's not spec.containers, it's spec.init containers. And if we look at that for our Emojivato pod, we can see an init container called Linkerd init, which is lovely. There should be an init container there. We're using it to configure the world. This is pretty horrible, but we can also look into the status element of our pod. There's an array in there called init container statuses. And we can use that to look into the status of each of our init containers and find out whether they worked or whether they didn't or whether they're stuck or whatever. I shall leave deconstructing this particular JSON path as an exercise for the reader. But if we run it, we'll find that the Linkerd init container is completed and it had an exit code of 0, which is success. So this is the happy path for the init container. I'm not going to show an unhappy path for the init container because we're already an hour into this. So instead, we will switch over and look at the CNI. All right. We're going to create an entirely new K3D cluster for this. Jason's mocking me for using JSON path instead of JQ. I didn't want to walk through installing JQ, Jason.
No, I'm not mocking you for using JSON path. I was just making fun of JSON path in general.
Yeah. There are all of the tools for messing with that stuff are just ugly. That's all there is to it. So once again, we're creating K3D. We're telling it not to deploy traffic. Now we're going to install the Linkerd extension. The Linkerd CNI extension. The Linkerd CNI extension is special. It is the only extension that you can install before you install the rest of Linkerd, and it must be installed before you install the rest of Linkerd, because Linkerd will rely on it to be there if you're trying to use the CNI. So let's go ahead and do that. We install the CNI, it creates the Linkerd CNI namespace, and hey, look, there's a Linkerd CNI daemon set running in our Linkerd CNI namespace, always a good sign. So after setting that up, we can go ahead and install Linkerd, and you will note that we have the Linkerd CNI enabled flag passed in here when we get to the Linkerd install command to tell it to, use the CNI. Install -- Linkerd CNI enabled, and off we go. Here again.
Just to answer Chris, Chris, you don't have to disable traffic in K3D. It's just the preference that both Flynn and I share, in that we don't like to add things to the cluster that don't particularly need to be there.
Part of the point of K3D for me is I want it to be very lightweight, because I sometimes need to be running more of them than people really ought to be running on a laptop and things like that. But yeah, if you, it's not actually functionally important. It doesn't really matter.
It's emotionally important though. It's emotionally important.
Yeah. It gets me right here, man, every time. But it's been 50 seconds since I started this, and we still have no running pods for Linkerd destination, which is decidedly not a good sign. I'm going to give it another couple of seconds here, but it has now been a minute, and things should be working inside of a minute. So I'm going to go ahead and bail from that. And let's take a look at our Linkerd pods. That is not what we should be seeing for Linkerd pods. You remember how I said that CNI problems tend to not be subtle? Yeah, so this is not subtle, right? What we're going to do here is we're going to take a look into the destination controller. And I'm picking on the destination controller. Why not, right? It doesn't really matter. Same trick before, we're just using a Kubernetes label selector to find this particular pod. We got its pod ID, and now we'll ask for its logs, to which it says, oh, hey, look, Linkerd proxy waiting to start because the pod is still initializing. Pod initializing in this context basically means, dude, your init container has not succeeded yet. Something is wrong. Okay, so if we go through and we look into this one, we can see it has containers called Linkerd proxy, destination, SP validator policy, and Linkerd network validator, which is the init container. Okay, well, let's see what the init container has to say for itself. What the init container has to say for itself is just connecting, and that's it. So that's a pretty good indication that our CNI plugin configuration has failed miserably, but the validator is doing its job and telling us that something is wrong and presenting it in a way that is not possible to miss this, right? So we're not actually going to go through the debugging exercise of figuring out what's going wrong here, because again, we're like over an hour into this already. So we're going to skip to the punchline instead. K3D uses Flannel for its network layer, which is fine. Flannel is fine. There's nothing wrong with Flannel. But it happens that K3D installs it in a way that's a little different from what the Linkerd CNI plugin is expecting. So we have two options. The first one is we can use, basically when we install Linkerd CNI, the extension, we can tweak the install paths that it's trying to use to line up with what Flannel and K3D expects, or we can always just run some other CNI inside K3D. We're going to tweak this install paths right at the moment because it's a little bit simpler than going through and downloading another CNI and setting things up and all that crap. But if there's interest, we could certainly do that one for some other workshop or another talk or something like that. So I'm going to delete our broken cluster and then restart it, or rather recreate it. One of the things I absolutely love about doing this with K3D is how quick it is to cycle a cluster. Okay, now we're going to reinstall the CNI, but we're going to pass these dest CNI netdir and dest CNI bindir flags, and hopefully that will do good things. Dominic says he'd love to know more about the Flannel debugging. That would be a great thing to bring to Slack. I learned about all of this by watching Matej go through it. So he will be a much, much better person to talk about that sort of stuff. At least he'll be a much better person to talk about it off the cuff. I think it'd be a fun talk to do.
Flynn, is your demo script for this available for folks that are watching if they want to try it out?
It is indeed. It's a little surprising. It's a markdown file.
Okay.
Yeah, this is the world's debut of using the demo tool to read all the commands out of a markdown file and execute them.
I love it. Yeah.
But yeah, it's in the Service Mesh Academy repo in the startup Init CNI. No, I don't remember the name of the directory.
Could we share it in the workshops channel after this is done?
We will absolutely do that. And
thanks so much.
I will also post something. I'll update that to point to the demo tool. I actually have to push the demo tool up to GitHub so other people can see it.
Yeah, so Bob actually asked about that. Bob, Flynn has written his own demo tool because he found that You found the ones that other people are using,
Uh,
it not quite enough for his use case. So it's a really
Well,
awesome thing, and we'll talk about it in the repo.
yeah, and in all seriousness, one of the things that we learned recently was having a README that's a markdown file and having a demo script that's a shell script means that they can get out of sync. And yeah, that's bad. Okay, so this time Linkerd did come up. And if we go through and we see what's running in there, this looks, pretty normal, right? Got the usual suspects running in Linkerd. That's great. So we'll go ahead and reinstall Emojiboto. Vyacheslav, I'm probably horribly mangling that name. I'm sorry about that. Notes that my keyboard has soft keys. Yeah, I don't think they're quiet enough for me to really be typing all this though. Okay, so here we have, yeah, my keyboard situation is a whole other story. Okay, so we got the usual. We have our pods, they're running. Each of them has 2 containers that show up as running. We're going to do the same trick where we're going to look to see what the containers are that are actually running in here. Last time we were just drilling into one workload, but in this case, I'm going to do the JSON path madness to look at all of them. And we can see that all of them have Linkerd proxy and their individual application container running. That's a good sign. We can check out lifecycle hooks and, okay, this one we will dig into one single pod. The formatting is just way too messy if you try to do that for all of them. Once again, we've got the await hook. So far, all of this is looking very much like the init container, right? Or like using the init container to set things up instead of using the CNI plugin. And the first bit of takeaway here is that, yeah, actually a lot of things do happen the same. You don't have to relearn everything as you switch between the 2 methods. But if we look a little bit more closely at the init containers, we will see they don't have anything now called Linkerd init. The init container is now called Linkerd network validator, just to further demonstrate that all this is doing is just checking to make sure that IP tables is correctly set up so that we can go on. The other thing I was going to say was if we did not install Edge 22.11.1, but we were doing this with Linkerd 2.12, you would see a container there called NoOp. NoOp is actually the name of the init container. It does not mean that Kubernetes could not find an init container. The NoOp init container does, nothing, basically. It has a purpose in life. The purpose in life is that there are CNI plugins that aren't ours, but some of the other CNI plugins require that your pod basically either has to have all of its containers already running, or it has to have an init container. One of those 2 has to be true before Kubernetes will assign it a pod IP. And some of the CNI plugins get very unhappy if they're asked to run before the thing has a pod IP. So yeah, there's some madness going on there with other CNI plugins. Okay, so that's actually the end of the demo. We've taken a quick look. Okay, maybe not such a quick look under the hood of the init container and the CNI plugin, and taking a look at what you should expect to see as you go through and look down at various bits of Kubernetes. There is, oh my God, there's so much more we could dig into with this one. I actually would kind of like to go through at some point and put together a workshop with, where we deliberately break some of these things. It turns out that figuring out how to make this break in kind of visible ways is even harder than describing it in the first place. So that's going to have to be a later workshop. But hopefully this is a good starting point for everything. And I see we have one more question in here.
Yeah, we have a couple of good ones. So
okay.
Sharik is asking, does the Linkerd CNI use AWS VPC IPs or virtual network CIDR? So I think Sharik, and let me know if I've got this right, Flynn, but I believe that like the Linkerd CNI is just a plugin. It's only using whatever else you're using for CNI to rewrite the IP tables rules. It's not providing you any sort of IP spaces or IPs.
That's my understanding, is that, yeah, it's not going to affect that. So whatever happens in your network normally is what's going to happen when you're using the CNI plugin. And it looks like Mate is expanding on that we're really paying a lot of attention to ports and things like that. We need to know what the IP addresses are. We don't have to know, we're not allocating them. We just need to know what their values are.
Yeah, and then Alejandro had a great suggestion to check out. There's a Linux Foundation course on Linkerd that kind of goes through a lot of this stuff in a fair bit of depth. And then we had a question from Dan in Slack about jobs, right? So specifically the Linkerd proxy and jobs, which great question, Dan. So essentially, I believe, Dan, what you ran into, and let me know if I got this wrong, is that your jobs kept running even after the job itself stopped because the Linkerd proxy didn't know to shut down. And Dan asks, are there any other type of resources that don't natively work out of the box? The answer is no. There aren't any other resources that have that problem. There's a whole thing with jobs, which is kind of separated into its own bit. And there's currently a KEP, which is a Kubernetes enhancement
proposal.
There we go. Thank you. Specifically to address that particular issue that there was some talk about on Twitter the other day. If you do want to tell resources, or if you do want to set at the namespace level that proxy injection should occur, but you want to omit proxy injection for a particular workload, you can do that by setting an annotation that is linkerd.io/inject disabled, and it will not get the proxy there. There's also some other options, and I'm happy to reach out to you on Slack directly about using Linkerd await as a wrapper to send a end signal to your proxy.
Just to be clear, the Jason's statement about the annotation to disable injection, you could set the namespace to allow injection and then override that injection at the namespace level by applying it on a deployment or a pod or a job or whatever. That might make a little bit more.
Thanks.
Pretty sure Dan knows that, but just to make sure that that's clear for everybody, just to make sure that that's clear. If I recall correctly, if I recall correctly, the KEP is talking about a fairly generalized way to talk about shutdown of various containers. And there are a couple other things that people have been kicking around, like a controller that will go through and notice that the job is done and kill the sidecar and things like that. But it is in general a hard problem, TM, in Kubernetes, unfortunately. What else do we have? Anything else? Well, early on, there was a question about Istio versus Linkerd, which we're always happy to talk about. The shortest version possible there is that there are things that Istio can do that Linkerd cannot do. On the other hand, Linkerd also focuses much, much harder on operational simplicity than Istio does. And that's a pretty big deal, especially if you want to run Linkerd without having somebody dedicated to the care and feeding of Linkerd, which you can totally do that with Linkerd, and it's much, much harder to do with Istio. I'm not sure it's possible to run Istio without a dedicated person on it, actually, or people.
Yeah, great answer, Flynn.
Anything else before we pick up a little bit with slide stuff?
Well, I'm curious, Flynn. Is there another workshop that folks can register for?
You mean another Service Mesh Academy?
Yeah.
Why, yes, in fact, there is. Look at that. December 15th, we will be doing a deep dive into MTLS with Linkerd. You will learn lots and lots of things about certificates and TLS and protocols and rotation and, you know, all that horrible stuff. And yeah, you'll learn why you really don't want to be doing all of this stuff by hand. So Catherine has politely posted the registration link in there. That's great. Thank you, Catherine. Oh, and we had another question from Parsa. Wait, maybe a couple.
And Mate actually just responded to that
Awesome.
in the chat.
Okay. Well, if that doesn't answer your question, Parsa, then let us know. But yeah, we will in fact continue doing these. We skipped Service Mesh Academy in October because we were all at KubeCon. But we're back, so we'll be doing this every month. We would be remiss if we didn't point out that if you don't want to deal even with the operational simplicity that Linkerd brings to the table, you can sign up for Buoyant Cloud and let Buoyant Cloud deal with all that stuff for you. And I think that that's about it. This is how to reach me. Flynn@buoyant.io via email, or at Flynn on the Linkerd Slack, or the CNCF Slack, or the Kubernetes Slack, or pretty much all the open source CNCF cloud native type Slacks. Alejandro asks, what about Gamma? There is no Gamma Slack. Sorry, that probably wasn't the question. Alejandro, could you clarify a little bit more? What about Gamma?
Well, actually, that's a great one, Alejandro, if you don't mind joining the Slack, that's a great question to just thread right there in the workshops channel with Flynn.
Yep.
So folks can talk about that
there is a very short answer to, you know, what about Gamma and Linkerd in general. The short answer is that I and Mate and a couple other folks from Linkerd are very actively involved with Gamma, and Linkerd is very interested in being able to have Gamma be something successful so that we can reduce the number of CRDs we have to teach people about. Okay.
And Bob really wants to know about that demo tool. And Bob, I'm with you. I also really want to learn about that demo tool.
Yeah, it's I've been remiss in not pushing it up. The honest reason that I haven't already published that on GitHub for everybody to see is that I feel really bad about the fact that it doesn't have any comments in the code right now. So I have to fix that. Yeah. Okay.
Thank you everyone for your time. Have a great rest of your day.
Thanks to everyone for attending, to Jason for emceeing, and to Mate for answering all the hard questions. All right. Thanks much, everybody. We'll talk later.